Exercise 6.1b, question 16. We have the vectors a and b are given by a equals t plus 3i plus tj plus t minus 1k, b equals 2 minus ti plus t plus 1j plus t minus 5k. Part A asks us to find a cross b in terms of t. Alright, so t plus 3, t, and t minus 1. So that's A crossed with negative t plus 2, t plus 1, and t minus 5. Alright, so if we delete the first row, it's t times t minus 5 minus t plus 1 times t minus 1. I think it's easy to make a mistake, so it's probably better to write out all the steps. Okay, so then for the second one, it's going to be 2 minus t times t minus 1, and then minus t plus 3 times t minus 5. And then lastly, it's going to be t plus 3 times t plus 1. And then minus t times 2 minus t. And all that's left to do now is just to simplify everything. So t squared minus 5t minus t squared minus 1. So that's the first column, the first row. And then it's 2t minus t squared, and then minus 2 plus t, and minus t squared plus 3t minus 5t, so minus 2t, and then minus 15. Okay, and then t squared plus 4t plus 3 minus 2t plus t squared. Bit of a tedious problem. Okay, so then we're left with 1 minus 5t. And so we're going to have minus 2t squared. How many lots of t? So 3t plus 2t, so that would be plus 5t. And then lastly, we got minus 2 plus 15. So that will be 13, plus 13. And then it's 2t squared plus 2t plus 3. Okay, and we're told that it's parallel to 1, 1, negative 3. So we have that this thing is equal to k times 1, 1, negative 3. Just make sure I got that right. Yep, 1, 1, negative 3. So this is part B now. And we have to find the value of t. No problem. So we have that 1 minus 5t is equal to k. Which is also equal to negative 2t squared plus 5t plus 13. So I guess actually we don't really need to do any more work. We can just observe that 1 minus 5t is equal to negative 2t squared plus 5t plus 13 and get ourselves a quadratic equation. So that tells us that 2t squared minus 10t, and then it's minus 12 is equal to 0, which is equivalent to t squared minus 5t minus 6 is equal to 0, which we can factorize, so that would be t minus 6 and t plus 1 equals 0. So we have t is equal to -1 or t is equal to 6. Of course, whatever t is, and whatever k is, the last coordinate also needs to be consistent. So if t is equal to -1, we have that k is equal to 6. And so then we must have that 2 times -1 squared, so 2 minus 2 plus 3 is equal to 6 times -3, which is -18. So that's definitely not true. So t equals -1 is actually not a solution here. However, if t is equal to 6, then we have that, so t equals 6, then we have that k is equal to -29 by this equation here, okay? And so we should also have that 2 times 6 squared plus 2 times 6 plus 3 is equal to -29 times -3. So k times -3. So that would just be 29 times 3. 20 times 3 is 60. 9 times 3 is 27. So that would be 87. And clearly solving this thing, it's the same as 2 times 36, which is 72, plus 12 equals 87 minus 3, which is 84. And that is indeed correct. So t equals 6 is our solution.